Hello and welcome back. In this tutorial, we will learn how to integrate using substitution. Let's say we wanted to find integral of the function x plus 1 squared dx. Of course, we can open squared and simplify this function and integrate step by step, but what if we wouldn't be able to simplify it? Well, we don't have the formula to integrate function x plus 1 squared. But what we know that we can integrate something like that. If we have integral of u squared du, then the integral is just u to the power of 3 divided by 3 plus some constant c. So in other words, if instead of x plus 1 I would have some one variable u, I would know how to integrate it. Let us make substitution. We let u equal x plus 1. So what we would obtain now is integral of u squared, but now we have times dx, and our variable is u. So we have to introduce du in terms of dx in terms of u. How to do that? Well, from this equation, u equal x plus 1, we have to introduce x in terms of u. So we have that x would be equal u minus 1. Now it's easier to find dx, which is just derivative of this function. So dx is equal derivative of u minus 1, which is just du. Now we have that dx is the same as du, and we obtained a new function, integral of u squared du. And we know how to integrate it. So it's u cubed over 3 plus constant c. Since we started with variable x, we have to come back to variable x. So now we're going back to our substitution and write x plus 1 instead of u. So our final result is x plus 1 cubed over 3 plus constant c. Let us do a few more examples. Let us integrate 1 over x plus 2 dx. So again, we don't have the formula for integration of 1 over x plus 2 dx. However, we know that if we would integrate 1 over u du, this is just a logarithmic function, natural logarithm of u plus constant c. So we make a substitution. We let u equal x plus 2. And now again, dx we have to introduce in terms of du. From here, we have that x is equal u minus 2. So dx is just the derivative of u minus 2. So it's just a du. Now we obtained a new form of this integral. So we have integral of 1 over u du, which is just natural logarithm of u plus constant c. And now we have to go back to our substitution. So instead of u, I just rewrite x plus 2. So final solution is logarithm of x plus 2 plus constant c. Another example, when we wanted to integrate, for example, exponential function e to the power of 5x dx. Again, I know formula for integral of e to the power of u du, which is just an exponential function itself. So my substitution will be u equal 5x, and now x I have to introduce in terms of u. So x equal 1 over 5 of u, and now derivative dx is equal 1 over 5 du. Now we have that our integral will be e to the power of u, and now dx is exactly 1 over 5 du. And I pull this constant 1 over 5 in front of the integral. Now we just integrate. We have 1 over 5 e to the power of u plus constant c. And we go back to our substitution. So it's 1 over 5 e to the power of 5x plus constant c. Now it's your turn to practice.